So as we look at the asteroid belt, we see that there's still a lot of material there. So why is it that this stuff didn't accrete, forming a single, much larger object? Well, based off of computer simulations, it is all Jupiter's fault. It is all because of Jupiter. So what happened is Jupiter is right there near the asteroid belt. Jupiter's strong gravitational pull did two things. One, it actually ejected material from the asteroid belt, clearing some of that material out so there's just less stuff, which is part of the reason why if you collected it all together, it would still be less mass than our moon. The other thing that Jupiter did is that its gravitational pull actually stirred up that material, so it wasn't able to keep colliding together gravitationally. Okay, so Jupiter reduced the overall mass and stirred everything up so it wasn't able to collapse. In fact, we actually still see evidence of Jupiter's impact on the asteroid belt today. As we look at the locations of where asteroids are within the asteroid belt, we find some interesting patterns. Okay, so this graph, up and down, we're looking at the number of asteroids, and along the bottom, we're looking at distance. So you can see the orbit of the Earth, here's the orbit of Mars, out there's the orbit of Jupiter. Through here is where we're looking at the number of asteroids. Notice that there are these regions where have these large dips in the number of asteroids. These regions where we have far fewer asteroids than normal, these are referred to as the Kirkwood gaps. And these regions correspond to places of orbital resonance. So we mentioned orbital resonance previously when talking about Io, Europa, and Ganymede, moons of Jupiter, as well as the Cassini division, which is this kind of gap in the rings of Saturn. An orbital resonance is where the orbits are even integers of each other. So in this case, if we look at this really large gap here, this is a 1 to 3 orbital resonance. What this means is that for every one time that Jupiter has orbited exactly once, the asteroids in this region have orbited exactly 3 times. Because of that ratio between their orbits, this means that Jupiter's gravity pulls on the asteroid at the exact same place in every single orbit. This means that Jupiter's gravity has slowly cleared out that region of these asteroids, which is why there are far fewer. So we actually have many of these regions. So right here is a 1 to 4 resonance. This smaller one is a 2 to 7. Here's a 3 to 7. Okay, so all of these regions are places where we have far fewer asteroids. These are, again, the Kirkwood gaps. Now, most asteroids are small and therefore are going to be really hard to actually get a good view of from the Earth. Now, that being said, that doesn't mean we haven't figured out clever ways of actually determining their shapes and sizes. One way we have of figuring out their shape is by looking at their brightness fluctuations. So the idea is that if you have an object that is perfectly round, so say like the moon or a planet, then, because it's perfectly round, no matter its orientation, the same amount of surface is going to be reflected towards you. So you don't expect a lot of color or of brightness variation. However, if something has a strange shape to it, then different amounts of it are going to point depending on its orientation. So, for example, in this case, we have a broad side pointing towards us. This means that a lot of light is actually going to be reflected towards us. However, on the end, you can see that it's much narrower. If that's pointing towards us, we're going to get a lot less reflected light. So as this thing rotates around, it'll get brighter and dimmer and brighter and dimmer, which gives us some information as to its shape. What regions are long, which ones are narrow. More recently, we've actually begun using radar to figure out what's going on. So the idea is that we send out a signal of radio waves, and some of those waves will then bounce off of the surface and come back to us. This will not only give us an outline of the shape of it, but it can even give us some depth information. Hey, this is actually an image, a radio image, reconstructed from one of these asteroids. The very best thing to do to get information on an asteroid is to actually get up close. So the Galileo orbiter, which actually flew past a couple of asteroids on its way to Jupiter, was able to get close and get some very nice pictures. The Near Shoemaker spacecraft orbited one until landing on a different one, and then more recently we've had the Hayabusa orbiter missions, which have been done by Japan. All right, here's our first question. What causes the Kirkwood gaps in the asteroid belt? A. Gravitational pull of the inner rings on the outer rings. B. Asteroid impacts. C. Shepherd asteroid sweeping up material. Or D. Orbital resonances with Jupiter. Go ahead and think about it, and we'll discuss in just a bit. Alright, so the Kirkwood gaps are these regions where we have far fewer asteroids than normal, and the reason why this happens is D, orbital resonances with Jupiter.